Welcome to the visual frontier of artificial intelligence. In this video, we explore computer vision, the field of AI that gives machines the ability to see and interpret our world. If you're preparing for the AI-900 exam, pay close attention. This section accounts for up to 20% of your total score. We'll begin by exploring the Azure ecosystem, from plug-and-play APIs to custom-trained models. From there, we'll dive into the science of pixels, moving from the microscopic grid level to the complex architecture of convolutional neural networks. Finally, we'll look at the modern era of multimodal models and the critical ethical considerations required to deploy these powerful tools responsibly. Let's get started. Welcome to the Azure Computer Vision ecosystem. Microsoft provides a tiered approach to vision, offering a toolkit that ranges from ready-to-use APIs to highly specialized machine learning environments. Azure AI Vision. First, we have the flagship, Azure AI Vision. This is built for developers who need sophisticated image and video analysis without building a model from scratch. Think of a smart city project where cameras need to identify unauthorized vehicles in a parking lot. It's all about fast deployment and cost-effective scaling. Azure AI Services. But what if your application needs more than just sight? When you need a brain that can listen, translate, and search, you use the unified Azure AI Services resource. Imagine a travel app. It sees a landmark, translates the plaque next to it, and searches for nearby hotels. The best part? You manage all these different AI brains with just one API key and one endpoint. Azure AI Custom Vision. Sometimes, general models aren't enough. When you need to identify very specific things, like a particular brand of tractor or a specific type of leaf rust in a cornfield, you need custom vision. In this workflow, you upload your own images and tag them. Azure then trains a specialized model just for you. Azure AI Face Service next is the Face Service. This is specialized for detecting and identifying human faces. It can pinpoint facial landmarks like eyes, nose, and mouth. However, because of responsible AI principles, access to recognition features, matching faces to specific identities, is restricted to ensure privacy and ethical use. Azure AI Video Indexer. Finally, for moving pictures, there is the Video Indexer. Think of this as vision for video. It uses over 30 AI models to pull out metadata. It can identify who is speaking, read on-screen text using OCR, and even sense the sentiment or emotion of the audio. From simple photo tagging to complex video insights, the Azure ecosystem provides the right level of customization for any vision workload. Azure AI provides 4 primary ways to interpret visual data. First is image captioning and tagging. Captioning creates a full descriptive sentence, while tagging generates a list of keywords. Both features include a confidence score from 0 to 1, telling you exactly how certain the AI is about what it sees. Second, we distinguish between classification and object detection. While classification simply identifies the main subject of an image, object detection pinpoints the exact location of multiple items using bounding boxes. This allows the AI to understand spatial relationships within a scene. Third is facial analysis. This goes beyond simple detection by mapping specific facial landmarks, such as the eyes, nose, and mouth. This level of detail is critical for security, accessibility, and privacy features like automated face blurring. Finally, optical character recognition, or OCR, converts pixels into searchable text. Using the Read API, Azure can extract text from the wild, turning images of signs, labels, and documents into digital, machine-readable data. Together, these capabilities allow Azure to see, locate, and read the world just like a human would. To a computer, an image isn't a picture. It's a complex math problem. Every image is actually a grid of numbers made up of pixels. In a standard 100 by 100 image, there are 10,000 individual pixels. In grayscale, each pixel is a single value from 0, which is pure black, to 255, which is pure white. For color images, it adds layers. Using the RGB model, every pixel combines red, green, and blue intensities to represent millions of different colors. But how does the AI recognize shapes? It uses kernels. These are small 3x3 grids that slide over the pixels to find patterns. A blurring filter averages values to remove noise. Edge detection highlights sharp changes in intensity to find outlines. Finally, sharpening increases contrast to make details pop. This mathematical filtering is how machines turn raw numbers into sight. The engine behind modern computer vision is the convolutional neural network, or CNN. It processes images through four key stages. First are the convolutional layers. These act like digital detectives. Early layers spot simple edges, middle layers identify shapes, and final layers recognize complex features like eyes or wheels. Next, pooling layers downsample the data. They shrink the image to focus only on the most important parts, making the processing much faster. Then, the data enters the fully connected layers. This is the brain where all detected features are gathered to identify the object. Finally, the activation stage, specifically softmax, delivers the verdict. It assigns probabilities to its guess, such as a 90% probability that the image is a dog. By filtering images from simple lines to complex objects, the CNN allows machines to see with mathematical precision. The newest breakthrough in AI is multimodal learning. Traditionally, AI was limited. Vision models only knew images, and language models only knew text. But the game has changed with models like Microsoft Florence. This technology uses something called embeddings, numerical codes that act like coordinates in a virtual map. In this mathematical space, an image of a cat and the written word kitten are placed side by side because the AI understands they represent the same concept. By linking sight and language together, we unlock incredible new tools. For the first time, you can search your massive photo libraries using natural language. Simply type caterpillar in a cornfield to find the exact shot. Even more importantly, it allows for high-speed, detailed video descriptions, providing a life-changing level of accessibility for the visually impaired. Multimodal AI isn't just about seeing or reading. It's about understanding the world exactly as we do. With great power comes great responsibility. Computer vision, and specifically facial recognition, is a sensitive technology that requires a foundation of ethics. The primary hurdle is the fairness challenge. Research has shown that if an AI is trained mostly on a single demographic, it becomes less accurate for others. This is known as bias. The result? Systems may have significantly higher error rates for women or people with darker skin tones. To mitigate this, Microsoft has taken a firm stance, prohibiting U.S. police from using its facial recognition and retiring features that guess gender or emotion to prevent harmful stereotyping. Beyond fairness, we must prioritize privacy and transparency. Consent is non-negotiable. Users must know when they are being recorded or analyzed. Furthermore, data governance is critical. Facial data is sensitive biometric information that must be encrypted and handled under strict laws like GDPR. Finally, there is explainability. Developers must be able to explain exactly how a system made a specific decision. In the world of AI, seeing is only half the battle. The other half is ensuring we see fairly and ethically. We've now covered the what, the how, and the should we of computer vision. From Azure's powerful services to the mathematical world of pixels and CNNs, it's clear that this technology is much more than just a camera. It is a sophisticated system of mathematical interpretation built on a foundation of responsible AI. To help you master these concepts, you can get free course summary notes by clicking the link and downloading them from the description.